Everyone, let us continue the solutions for UGC NET Electronic Science question paper conducted on August 2024. The last section is part 4. ECG represents the electrical activity of the heart. So this is related to ECG. So electrocardiogram, it represents the electrical activity of heart and composed of various frequency components. So QRS complex has high frequency components, complex has high frequency components, and P wave and T wave has low frequency components. So these gamma waves are associated with high cognitive function, that is memory, concentration and learning, and the frequency range is from 30 Hz to 100 Hz. Next, theta waves are associated with relaxation, light sleep, and the frequency range is from 4 Hz to 8 Hz. Next, QRS interval is from 0.12 to 0.2 second, and QT interval is PR interval. QRS interval is, so this is for PR interval. So PR interval is from 0.12 to 0.12 to 0.2 second. QRS interval is, the normal cases it is less than 0.12 second. So then PR interval is 0.12 to 0.2 second. Q2 interval is 0.32 to 0.5 second, and ST segment is 0.08 seconds. So from this, the correct option is 1. So for gamma rays, it is 30 to 100 hertz, so 22 to 30. So this is for gamma. Next, it is theta, it is B, 4 to 8 hertz, normal hertz. Next is QRS interval. So QRS interval is option 2, 0. It is less than 0.12 second, so that is 0.05 to 0.1 second. Next, PR interval is 0.12 to 0.2 second. So correct option is 1. So this, some more information related to this is, P wave is related to arterial depolarization, and its frequency is 0.5 to 10, 0.5 hertz to 10 hertz, and QRS complex is related to ventricular depolarization, and the frequency range is from 10 hertz to 40 hertz. Next, T wave is related to ventricular repolarization, and U wave is related to small deflection repolarization. So this T wave and U wave are related to repolarizations. And the frequency range of T wave is from 5. The frequency range of T wave is from 0.5 hertz to 10 hertz, and the frequency range of U wave is less than 2 hertz. So QRS complex has highest frequency component, P wave and T wave has low frequency component. So the correct option is 1. Next question. The following instructions in 8086 searches the table of 100 bytes for 0AH. Select the correct option. So A is STC. STC means set carry flag to 1. CLC is clear or reset carry flag to 0. CLD is clear direction flag, reset direction flag to 0. REPNE is repeat the given instruction till CX not equal to 0 and ZF is equal to 0. And REPE is repeat the instruction till CX not equal to 0 and ZF is 1. JCXZ, jump if CX register is 0. So the correct option is C. Next question. A PMMC instrument has 3 resistor Ariton shunt. It is a PMMC meter. Ammeter with shunt resistance is given, and it is connected to point C. What's the current range of ammeter when it is connected to point C? So range of ammeter when it is connected to point C. So here the full scale deflection current is for the meter full scale deflection current is 100 microamperes and meter resistance is 1 kilo ohm. We need to calculate the shunt resistance, and the formula for shunt resistance calculation is I is equal to 1 plus Rm by RSH into Im, where Im is a full scale deflection current, Rm is a meter internal resistance, RSH is a shunt resistance, I is a current to be measured. Therefore, shunt resistance, we need to calculate the shunt resistance RSH. So from this, I is now shunt resistance is 0.05. So that is R1 plus R2. So shunt resistance is R1 plus R2. So that is 0.05 ohms plus 0.95 ohms. Its value is 1 ohm. Now current I is 1 plus 1000 by 1. Rm by meter resistance is 1000. Shunt resistance is 1 ohm into meter current, that is 100 microampere. 100 microampere 10 power minus 6. The total current that it can be measured is 100 milliamperes. So correct option is 3. Next question, hardware descriptive language. So this hardware descriptive language describe the structure and behavior of digital and logic families. So first option is correct, and these are used to model. These hardware description languages are used to model, simulate, test, and implement the digital circuits. Test and implement digital circuits. These hardware description languages are used to model, simulate, test, and implement the digital circuits. And two IEEE supported hardware description languages commonly used in industry and academia are Verilog and VHDL. So this IEEE supported are Verilog, VHDL. So VHDL means very high speed integrated circuit hardware description language, and other HDLs are System Verilog and System Verilog. So this is VERI. And System C. So these are the four languages supported by IEEE. And Verilog is based on C programming. Verilog is based on C programming, and VHDL is not based on the C programming. So now see the behavior of analog circuits. So it is wrong. It is a behavior of digital circuits. That it describes the behavior of structure and behavior of digital circuits and logic families. It is not analog circuits. So this VHDL is not based on the C programming. Correct statements are A and C. The correct option is 2. Some more points is Verilog is based on C language and VHDL is based on Ada and Pascal languages. VHDL is not case sensitive, but Verilog is case sensitive. This Verilog is less complex and newer language than VHDL. VHDL is complex. Next question. Using mesh analysis, find the current I1 for the given circuit given below. So for the given circuit, let A be the node and the node voltage is V. So let V be the node voltage at node A. So apply KCL at node A. So that is V minus 65 plus 13 by 6 plus V by 5 minus 8 by 5 is 0. So from this node voltage V is 28 volts and the current I1 is minus of V minus 65 plus 13 by 6. So from this current is 4 amperes. The current in the circuit is 4 amperes. Next question. Op amp in comparator mode. So from B and C, the op amp, there is no feedback for the op amps. Here there is no feedback. Here is also no feedback for this op amp. Here is also no feedback. But in C statement, so this op amp input is connected to inverting input terminal. In B statement, op amp input is connected to non-inverting input terminal. If here it is In both open loop case, output is plus or minus saturation. If input is connected to non-inverting input terminal, then output starts from plus V saturation. So for B it is 4. So in C statement, op amp is connected to non-inverting input terminal, so output will start from minus V saturation. For C it is 1. So for B, B is 4, C1, B4, so B4, C1, B4 and C1. Next C. For diagram A, so there are two Zener diodes connected back to back. So the correct output diagram is 3, and input is also connected to negative terminal, non-inverting terminal. Hence it starts from minus of Vz plus Vd1. For this D diagram, D1 is Zener diode and D2 is a normal diode. So in this case, the output is minus V saturation and Vz plus Vd2. These are the limits of the output. So correct option is 2. So they have given 4 different diagrams related to op amp with feedback and without feedback, and in feedback of different elements in the feedback related to the comparators. Next question. So for a stable system stone shown below, so we need to they ask to calculate steady state error and velocity error constant. So steady state error for ramp input is ESS is equal to 1 by kb. So steady state error for ramp input is 1 by kb, where k is a static velocity error constant and is a measure of system steady state error when input is ramp signal. When input is ramp signal or ramp function. So steady state error is 1 by kb. So kb is velocity error constant. It is given as limit s tends to 0 s into g of s h of s, g of s into h of s. Here g of s is s plus 2 by s plus 4, 4 by s into s plus 1. So this is g of s. These two blocks are in cascade connection. So gains are product of individual gains. And feedback transfer function gain h of s is unity. So therefore velocity error constant is s into g of s is s plus 2, s plus 4, s into s plus 1 by 4 into h of s is 1. So substitute s is equal to 0. So here it will get cancelled. Now s is equal to 0, and substitution we will get this velocity error constant kb value is 2. So from this kb is 2. So from this steady state error for ramp function input is 1 by kb. So that is 1 by 2, 0.5. The correct option is 2 and 1 by 2. Next question. For 8086 microprocessor interrupt system, which of the following statements are true? So type 0 interrupt represents division by 0, and type 1 it represents single step execution, and type 2 is a non-maskable interrupts and is used in power failure conditions. Type 3 is breakpoint interrupt, and type 4 is overflow interrupt. So the definition of interrupt is a condition that halts a microprocessor temporarily to work on a different task and returns to 0. For type 0 interrupt, the starting address is 0000h. For type 1 it is 0004h, and for type 2 it is 0008h, and so on. So now the correct statements are: type 0 is division by 0, statement A is correct. Type 1 is single step execution or debugging the program, so it is wrong. Type 2 is non-maskable, and type 4 is overflow. So statement B is C are wrong, and statement A D are correct. So correct option is 4. Next question. 8086. So IE0, IE1, TF0, TF1, these are the interrupts related to 8086 microcontroller. So this 8086 microcontroller has 6 interrupts. That is, so reset, which is having the highest priority. So highest priority interrupt in 8051 microcontroller is reset. So this is of highest priority. Next, timer 0 overflow, timer 1 overflow, external interrupt 0, external interrupt 1, and serial port. Now, each interrupt has a specific place in the code memory where program execution begins. Reset interrupt has highest priority, and the address of the reset interrupt is 0000H. Next, external interrupt whose flag is IE0. External interrupt 0 whose flag is written as IE0, and the address is from 0003H. And timer 0 overflow, that is TF0 flag, whose address is 000BH. Next is INT1. So external interrupt flag is IE1, and address is 0013H. So this is INT0 interrupt, INT1 interrupt. So this is timer 0 interrupt, and this is timer 1 interrupt, and the address is 001BH. So whose flag is TF1. So for flag here is RIRTI. The address of this interrupt is 0023H. Interrupt vector address is 0023H, and it is serial interrupt. So these are the various interrupts in 8051 microcontroller. So reset interrupt is having the highest priority, and address is from interrupt vector address is 000H, and interrupt vector address for IE0 and IE1 is 0003H and 0013. Similarly, for timer 0 overflow and timer 1 overflow is 000BH and 001BH respectively. For serial communication, it is 0023H. So now the correct option is 3. For IE0, it is 0003H. For IE1, it is 0013. For IE1, 0013. For TF0, it is 000B. So TF0. Next, TF1, it is 1B. Correct option is 3. Next question. For the circuit shown below, arrange the Z parameters in descending order. So first we will calculate the Z parameters and then arranging the Z parameters in the descending order. So these Z parameters are impedance parameters or open circuit parameters. It is given by V1 is equal to Z11 I1, Z12 I2, V2 is Z21 I1, Z22 I2. So this Z11 and Z21 are calculated when open circuit, when second port is open circuit. For I2 is 0, when port 2 is open circuited, that is I2 is 0, then we can calculate Z11 and Z21. So when port 2 is open circuited, then voltage V1 is 2I1 plus 2I1, so that is 4I1. So from this V1 by I1 is 4, so that is Z11 is 4. Similarly, V2 is 2I1, so V2 by I1 is 2. V2 by I1 is 2. So this is Z21. When port 1 is open circuited, so corresponding port 1 is open circuited, the current I1 is 0, only I2 current will exist. So now V2 is 5I2, V2 by I2 is Z22, so that is 5 ohms. Next, V1 is 2 into current I1 is 0 ampere minus 2I2 plus 2I2, so that is V1 is 0 times of I2 current. So now V1 by I2 is 0, so that is Z12 is 0. Now the Z matrix is, the corresponding Z matrix is Z11 4, Z12 2, 0 and 5. So this, now increasing order of Z parameters are so decreasing order of Z parameters are Z22 is 5, which is highest, and then Z11 followed by Z12 followed by Z21. So correct option is D, A, B, C. Next question. For the circuit, Thevenin's equivalent circuit is, so for the given circuit, and this is a circuit given, this is a circuit given. For this circuit, we need to calculate the Thevenin's equivalent circuit. So in this circuit, one voltage source is given VAB by 4. It is dependent current source is given. Independent voltage source is 6 volts and dependent current source is given VA, voltage dependent current source, whose is VA by 4. So for this circuit, for these kinds of circuits, while calculating the Thevenin's resistance, we need to keep a test source. We need to connect a test source across the terminals AB. So let us assume 1 volt test source is connected. So 1 volt test source is connected across the terminals for calculating the Thevenin's resistance. So 1 volt test source is connected because there is an independent source in the network. So 1 volt test source is connected. Now calculate the Thevenin's resistance. Let V be the node voltage at node A. So apply KCL at node A. So from that, node equation is 1 by 8 minus 1 by KCL equation is V by 8 minus 1 by 4 plus V minus 1 by 10 is equal to 0. So from this, voltage is 1.555. Now Thevenin's resistance RTH, because this is the Thevenin's resistance, we need to calculate the Thevenin's resistance. RTH is test volt test to test source voltage, that is 1 volt by 1 volt by current I1. So let us assume this is the current I1. So from this circuit, current I1 is 1.555 minus 1 volt by 10 ohms. So that is current is 0.555 by 10. No. So 1 by I1 is 0.555 by 10. So RTH will become 18 ohm. Thevenin's resistance is 18 ohm. Now to calculate the VTH. So again to calculate the VTH, this is a current I flowing. Let V be the node voltage at node A. So then current through 10 ohm resistance is 0. So current flowing through this, it is open circuited. The terminals A and B are open circuited. The current flowing through 10 ohm resistance is 0. Now voltage, this voltage V is equal to VAB because the current flowing through 10 ohm is 0. Now VAB minus 6 by 8 minus VAB by 4 is 0. So from this, VAB is equal to minus 6 volts. Thevenin's resistance is 18 ohm and VAB is minus 6 ohm. The equivalent circuit is 6 volts and 18 ohms. This is the Thevenin circuit. VTH and RTH across the terminals AB. So this entire circuit is replaced with 6 ohm and series with 18 volt source. So correct option is 4. Next question. Compared to gallium arsenide and indium phosphide based HBT, the silicon germanium HBT has lower cutoff frequency because of, so this silicon and silicon germanium heterojunction bipolar transistor have lower cutoff frequency than gallium arsenide or indium phosphide heterojunction bipolar transistor due to lower energy band and low mobility. Due to lower energy band and low mobility in silicon. Low charge carrier mobility in silicon. There are two reasons. One is lower mobilities and lower energy gap. So option 1 is correct. Next question. In data communication, modems. So this modem is nothing but a modulator and demodulator. It is a hardware. Modem is a hardware device that converts analog signal to digital signal and digital signal to analog signal. The output of modem is a digital signal. that carries digital information. So modem output is digital signal. Next, in the modem transmitter, digital to analog converter is used. In modem receiver, analog to digital conversion is you analog to digital converter is used. Modem transmitter can use digital to analog converter to produce analog drive signal, and this analog drive signal is received by modem and then converted to analog to digital signal. So correct option is correct statements are A and B. The word modem is the contraction of word modulation and demodulation. Correct. Modem is an interface between digital terminal equipment to analog communication facilities. Correct. Modem transmitter is having a analog to digital converter. No, transmitter consists of digital to analog converter. The output of modem is a digital signal carrying analog information. The output of modem is a digital signal that carries digital information. So statement C is wrong and statement D is wrong. Next question. So given the block diagram of cathode ray oscilloscope. So cathode ray oscilloscope is a versatile electronic device, electronic measurement equipment that provides accurate time, amplitude, and phase measurement of signals. The signal will be displayed on the screen, CRO screen. So this is a block diagram of cathode ray oscilloscope. In this block diagram, so the input one is vertical amplifier. So this is vertical amplifier, and second block is delay line. Vertical amplifier, delay line. CRT is there. In CRT there are horizontal deflection plates and vertical deflection plates. This delay line is connected to vertical deflection plates, and horizontal amplifier is connected to horizontal deflection plates, and this horizontal amplifier is driven by time based generator. The timing signals to the time based generator is given from the trigger circuit. Next, input signal is applied to vertical amplifier. Input is applied to vertical amplifier. So from this comparison, the correct sequence. So one is vertical amplifier. Vertical amplifier is connected to delay line, that is 2 is C. So one is vertical amplifier and 2 is delay line, and the delay line is connected to vertical deflection plates. So vertical deflection plates. Okay. Next, 3. 3 is A, that is trigger circuit. So trigger circuit is 3. Trigger circuit is given to horizontal amplifier. Before that there is a time base generator. D is 4 and this is 5. Let us see some more points. So vertical amplifier, it amplifies the input signal which is displayed on the CRO screen. Delay line provides some amount of delay to the signal. Next is trigger circuit. It produces a triggering signal to synchronize the both horizontal and vertical deflection electron beam. Next is time based generator, horizontal amplifier. It amplifies a sawtooth signal because the output of this horizontal amplifier is a time based generator is a sawtooth signal, and that is given to horizontal amplifier which amplifies the sawtooth signal. Next is power supply and CRT tube. Next question. The minterms of the following equation is, so in the given expression is a bar c bar a bar d bar ab bar plus bd. So minterms is, so minterm in standard SOP or canonical SOP form, each product term contains all the variables or literals either in complemented form or uncomplemented form. So this is a minimal expression. So we need to expand this expression. So that is, first expression is a bar c bar. So there are two literals. So b and d are missing. So a bar missing literals have four combinations: b bar d bar b bar d b d bar and then bd. So that is a bar c bar b c bar d a bar b c bar. So this is c bar and this is bd. So next, for next minterm, a bar and d. So here missing variables are b and c. So that is a bar d, missing variables are b and c. So b bar c bar b c bar b bar c b c bar and then bd. So this is four minterms: a bar d a bar and d. Similarly for A bar B missing are C and D. So C and D are missing. That is C bar, D bar, C bar D, C D bar as well as C D. Similarly for B D. So here missing variables are A and C. Missing variables are A and C. So that is A, B, C, D. So A bar, C bar. Next here it is A bar C, A C bar, A C. So from this remove all the common terms. Now we will get the expression as the, so this is M naught, M1, M3, M4, M5, M6, M7, M13 and M15. So A bar, B bar, C bar, D bar. So this is M naught. A bar, B bar, C, D. So this is M1. A bar, B, C, D bar. So it is M3. So like that, all the terms are, we need to write all the terms and common terms are replaced with a single term so that we will get the final expression f of ABCD. The function f of ABCD consists of these canonical terms, these min terms. So correct option is so 0, 1, 2, 3, 13 and 15. Correct option is 3. Next question. So this is a paragraph question. For this paragraph, 5 questions are given. First question is to increase the capacity of cellular system. There are 3 methods to increase the capacity of cellular system. One is various methods to increase the capacity of cellular system are one is cell splitting. Cell splitting. So splitting larger cells into a smaller ones to increase the number of available channels per unit area. And the second one is cell sectoring. Cell sectorization, replacing omnidirectional antennas with directional antennas to divide the cell into sectors. And third method is introduce new channels, introducing more channels into cell, introducing the more channels into a cell, assigning more channels to the cell. And the fourth one is frequency reuse. So dividing the coverage area into smaller cells, that is microcells, picocells, and femtocells, and reusing the same frequency band in non-adjacent cells. So these are the various methods to increase the capacity of a cellular system: cell splitting, cell sectoring, introducing the more channels into a cell, or frequency reuse concept. So correct option is 1. Next question: the number of cells in the cluster in a hexagonal cellular system is given by given with I is equal to 3 and j is equal to 2. So the number of cells in a cluster is represented by c is equal to I square plus j square plus ij, where I and j are non-negative integers. So replace I with 3 and j with 2. Now we will get 3 square plus 2 square, that is 4, 9 plus 4 plus 6. So its value is 19. 9 plus 4 plus 6 is 19. 19 cells per cluster. So this is an image for the 19 cell reuse. Next question. So here correct option is 3. Next question. The total capacity of cellular telephone system comprising of 10 clusters with 7 cell in each cluster and 10 channels per each cell. So that is size. We need to calculate the total capacity. 10 channels, 10 channels per cell. There are 7 cells in cluster. 7 cells per cluster multiplied with 10 clusters. So this is the total capacity of cellular system. Now the total capacity is 10 into 7 plus 10, 700. 700. So cell cluster will get 700 channels. 700 channels. The total capacity is 700 channels. Next question. Traffic is measured in. So generally the units for traffic is erlongs. So erlong represents a traffic load or call volume within the network. So 1 erlong represents continuous use of one voice channel for 1 hour. So that is given as A is equal to lambda t, where A is traffic load in erlongs, traffic load in erlong, lambda is average call arrival rate, average call arrival rate, and T is average call duration. T is average call duration. And there is Erlang B formula and Erlang C formula also. This Erlang B formula is used for systems with blocked calls cleared or used for the systems when blocked calls are lost. Example, cellular networks. So Erlang B formula is given as a power c to c factorial sigma n is equal to 0 to c a power n by n factorial, where c is the number of channels, a is a traffic load in Erlang's, and b is the probability of blocking. Similarly, Erlang C formula, so that is used for systems with blocked calls delayed. So example is call centers. Example is call centers, and it is given by this formula where c dash is a probability of users waiting, or when users are placed in a queue. Erlang C formula is used to measure the traffic. Next, GSM bands. GSM stands for Global System for Mobile Communication, and the bands in GSM 1 and 2 are 900 megahertz and 1800 hertz, 900 and 1800 megahertz respectively. Each GSM carrier frequency each GSM carrier frequency is 200 kilohertz wide, and each carrier is divided into 8 time slots, 8 time slots using TDMA, time division multiple access. The width of this each carrier frequency used in GSM is 200 kilohertz wide. Next, GSM operates in specific frequency bands which varying depend upon the region and the type of GSM network. So these are the various regional variations of GSM. GSM operates on specific frequency bands which vary depending upon the region and type of GSM network. So regional variations, Europe, these are the three regions mentioned, and these are the bands. So one more images is given. So primary GSM bands and extended GSM bands. So these are primary GSM band, extended GSM band. Primary GSM band uses lower frequencies, and extended GSM band. Next question. Next comprehension is given. It is related to signals and systems. So the output of continuous time LTI system is given. It is found to be 4 into e power minus 3t when input x of t is u of t. So then initial input, with the help of initial output and initial input, we need to find the transfer function. Using the transfer function, if input is e power minus t u of t, then what will be the output? That is the question. So in for output 1, so this is output 1 c1 of t. So this is input 1 x of t is x1 of t, but the transfer function of the system doesn't depends on input and output. Now the transfer function is here c of s is Laplace transform of c of t, that is 4 into e power minus 3t. So Laplace transform here is 4 by s plus 3. Next, c1 of s. Next, r1 of s is Laplace transform of input r1 of t. So r1 of t is u of t. U of t Laplace transform is 1 by s. So it can be written as r1 of t. So c1 of t. Now the transfer function is c of s by r of s. So its value is 4s by s plus 3. So for input r2 of t, for second input r2 of t is e power minus t u of t. Now r2 of s Laplace transform is 1 by s plus 1. Now transfer function is given, r2 of s is 1 by s plus 1. Next c2 of S. C2 of S is H of S into R2 of S. So H of S is 4S by S plus 3 and R2 of S is 1 by S plus 1, and it can be written as 4S by S plus 3 S plus 1 can be written as 6 by S plus 3 minus 2 by S plus 1, and take the inverse Laplace transform. Inverse Laplace transform of C2 of S, so that is C2 of T. Inverse Laplace transform is minus 2 e power minus t plus 6 e power minus 3t into u of t. So this is the output for the input e power minus t into u of t. So correct option is 2. Next question. For the following signal flow graph of IAR system, we need to find the direct form to realization. Direct form to realization. So direct to filter, digital filter transfer function can be realized in two ways, that is recursive and non-recursive. Recursive realization is used for FIR filters and non-recursive realization is used for IIR filters. For FIR filters, current output is a function of past and present inputs. For non-recursive realization, that is for IIR filters, the current output is a function of past and present inputs as well as past outputs. This IIR filter can be realized in many ways, that is direct form 1 realization, direct to form 2 realization, transposed direct form realization, cascaded form realization, parallel form, as well as lattice ladder realizations. The indirect form 2 realization, as per the questions, the number of multiplications are m plus n. The number of multiplications are m plus n plus 1, m plus n plus 1. There are in direct form 2 realization, there are m plus n plus 1 multiplications, m plus n additions, and maximum of m comma n memory locations. Next, see, as per the question, in direct form 2 realization, so this can be written as, so let us assume w of z as some intermediate node, then x of z as z transform of input, y of z as z transform of the output. Now w of z by x of z is equal to 1 by 1 minus 0.9 z inverse. So now x of y of z by y of z by w of z. So this is given as 1 plus 0.75. This is a forward path numerator. These two are backward paths come in denominator. 1 plus 0.5 z inverse by 1 minus 0.9 z inverse 1 plus 0.3 z inverse plus 0.7 z power minus 2. Now y of z by x of z is equal to y of z by x of z is w of z by x of z multiplied with y of z by w of z. And the final expression will become 1 plus 0.7 z inverse by 1 minus 0.9 z inverse 1 plus 0.3 z inverse plus 0.72 0.7 z power minus 2. So the correct option is 3. Next question. In order to recover in order to recover the finite length sequence x of n of length n from equally spaced samples of Fourier transform, the minimum number of samples of Fourier transform is taken is, so n. Option 1 is correct. So the minimum number of samples for Fourier transform needed to recover a finite length sequence x of n is of length n is n. This is a direct consequence of Nyquist theorem. This is a direct consequence of Nyquist Shannon sampling theorem, Nyquist Shannon sampling theorem applied to discrete Fourier transform. Next question. Given discrete time signal x of n is represented as, so this is discrete time signal x of n given if this discrete time is reversed. So that is reversal of the signal. Once the signal is reversed, the signal will become like this. Then the signal is shifted by 2 units right, so that is x of minus n plus 2. Resultant diagram is like this. So the correct option is 4. Next, there are two sequences are given, x1 of n and x2 of n, and they ask to calculate the circular convolution of the sequence. So circular for given there are two methods to evaluate the circular convolution of sequences. One is concentric circle method, and second is matrix multiplication method. So the given sequence x1 of n is 1, x1 of n is 1, 1 minus 1 minus 1 and 0, and given sequence x2 of n is 1 0 minus 1 0 and 1. So this starts from n is equal to 0, it starts from n is equal to 0. This is sequence x1 of n, and this is sequence x2 of n. Now by using circular convolution method, this is a procedure for circular convolution. Replace x1 of n here, x2 of n here. So x1 of n is 1 1 minus 1 minus 1 0, x2 of n is 1 0 minus 1 0 and 1. So using matrix multiplication, we will get the resultant as, so like this: 1 1 0 minus 1 0 0 1 1 0 minus 1 minus 1 0 1 1 0 0 minus 1 0 double 1, and then 1 0 minus 1 0 1. Into the sequence 1 1 minus 1 x1 of n, that is minus 1 and 1. So on matrix, by doing matrix multiplication, 1 0 minus 1 0 1 double 1 0 0 double 1 minus 1 0. So now we will get, by using matrix multiplication, the resultant sequence is 3 0 minus 3 minus 2 and 2. So now circular convolution of x1 of n and x2 of n resultant in third sequence, that is 3 0 minus 3 minus 2 and 2. The correct option is 4.